Okay, this is just separating the variables again, as we've done on previous examples. We're going to get logs in it yet again. You don't always get logs. One of our integrals is not going to be a log this time. Okay, so dy over dx. I've got to get rid of the dx. I want dy on one side. dy equals 1 plus cos y over 2x squared sine y, but I'm multiplying by the dx, so I've got a dx at the end. Okay, but now if you look at this, the 2x squared, well, the x squared's in the right place. Okay, the sine y and the 1 plus cos y are in the wrong place, and I'd much rather have a constant like 2 on the top of a fraction than on the bottom. So I'm going to multiply by 2. What I'm going to do is I'm going to multiply by 2, and I'm going to multiply by sine y, because the y's are on the wrong side, and I'm going to divide by bracket 1 plus cos y. So if I do all of that, then I get this fraction. There's just 1 times dy at the moment, so I'm going to have 2 sine y over 1 plus cos y, okay, times the dy. And on the other side, I've got rid of that. I've got rid of everything except the x squared on the bottom. So I need a 1 on the top, and I've got a dx. And of course, I need an integral on that, and I need an integral on this to be mathematically respectable. And now I've got 2 integrals to do. Well, 1 over x squared, okay, I have to remember is x to the power of minus 2. So this is not a log. Okay, although it's a fraction, this is actually I can do with negative powers using the power rule. So add 1 to the power, and the new power is x to the power of minus 1. Divide by that new power, and I got minus x to the power minus 1. And on this side, I always get my plus c. Now on the other side, okay, 1 plus cos y on the bottom, 2 sine y on the top. Well, when I differentiate the bottom, I don't quite get the top. If I differentiate 1, it goes. If I differentiate cos y, I get minus sine y. Okay, remember cos differentiates to a minus sign. So the integral I could do would be minus sine y on the top over 1 plus cos y dy. So I can do this integral. It's a log. It's log of the bottom. But it's not the same as that integral. I can't change this one, so I have to change here. Well, to make the minus go away, I need a minus. And to put the 2 in that I need a 2. So minus 2 times minus sine y does equal that. Good. So now I can do the integral. So this is minus 2 times log of the bottom. Don't need modulus signs unless something bad happens, which it won't. Equals, don't need the plus c on that side because I've got my plus c on the other side. Okay, we only need plus c on the right hand side on a differential equation. And have I finished? I've got to find the particular solution where y equals pi by 3 when x equals 1. So I could actually just find out this plus c and leave the answer like that. But I think you need practice anyway in getting rid of logs, so I'm going to do that. So let's divide by the minus 2. So log of brackets 1 plus cos y equals, I've got to get rid of the minus 2 because I can't make the log go away with that minus 2 there. Okay, so I need one side to at least have a nice log. The other side, divide by minus 2, well that's going to be plus a half x to the power minus 1, okay, and then we've got minus a half c. Now I don't care, that's it's just a constant, isn't it? But I'm going to make the logs go away anyway, so this constant here is going to become times a constant. Okay, this looks like a subtraction, but any subtraction is really an addition. I'll show you how it works. Okay, so what we're going to do is we're going to do e of both sides. So I'm going to have to go in columns again. Oh no! So so when I e the right hand side, the log goes away. So I'm going to get 1 plus cos y. And when I e this, I'm going to need some scribble space. I'm going to e this bit here. So I need to do e to the power of half x to the power minus 1 minus a half c. Now, because of laws of powers, I could split this into e to the power of the first thing divided by e to the power of the second thing, but I'm going to choose to view this as an addition because it's nicer. I'm going to choose to view this as e to the power of half x to the power minus 1 times e to the power of minus a half c. So I can regard it as being the half x to the power minus 1 plus the minus a half c. And that gives me a multiplicative constant a. So as we were expecting, we're going to get a times an e thing. Okay? And in fact, I think I've done it all because in this particular case, simplifying e to the power, there's no log in that. So I'm just going to leave that as that. So I'm going to have a e to the power of a half x to the power minus 1. And now I've got to find y equals pi by 3 when x equals 1. So I'm going to substitute those things in. So 1 plus cos of pi by 3 equals a e to the power of a half x to the power minus 1. Half times 1 to the power of minus 1. Now 1 to the power of anything is 1, so this is e to the power of a half. And cos of pi by 3, your calculator will tell you, is a half. So this is actually 3 over 2. Try it on your calculator if you don't believe me. Make sure you're in radians, of course. So 3 over 2 equals a times e to the power of a half. Okay, so therefore, okay, I want to know what a is, and I think I'd like to know what a is as a power of e, because look, my general solution has got a's times e's, and if a is in terms of e, then I'm going to be able to simplify that, aren't I? So I'm going to say I'm going to divide both sides by e to the power of a half, except I'm going to do that by multiplying both sides by e to the power of minus a half. Okay, because e to the power of a half times e to the power of minus a half, the powers add up to 0, that's e to the power of 0, which is 1. So you can just write this, you don't need to write that bit in. Okay, so I've got a equals that, so my 1 plus cos of y equals a, which is 3 over 2 times e to the power of minus a half. Okay, times, so that was my a, times a half, sorry, e to the power of a half, x to the power minus 1. And now I can do 1 plus cos y, okay, equals, and I've got an e times an e, so it's 3 over 2, and then we've got e to the power of minus a half plus a half x to the power of minus 1.